using them to simplify or rewrite some properties of or some logarithmic expressions. And so that's what we're going to do here. It says write each expression as a sum and or difference of logarithms and express your powers as functions or as factors. And so let's dive into this first example and see what it is we're talking about. And so we want to rewrite this as a sum or difference of logarithms. Okay, the only property that really does that is these two guys right here, those 3 and 4 that we just looked at. And so what we can look at is, okay, here's x times that square root x squared plus 1 inside a logarithm. So we can rewrite this as two separate logarithms separated by a sum. From there, we can actually go a little bit further. This first piece is done. Log base a of x can't really go any further. But this second piece, that square root, if you think back to what that's the same as taking a 1/2 power, right? So it's a square root, it's the same as 1/2 power, which means we can do this last part right here, express powers as factors. We can take this 1/2, we're just going to drop it down in front there, make it a factor. Multiply that logarithm by 1/2. And now that's done. We don't have any more any more products inside the logarithm or quotients that we can separate out. All the powers are factors, so we're finished. Just really using those properties, trying to get used to how they work. Okay, here we've got a quotient inside this natural logarithm. So we can make it natural log x squared minus natural log of x minus 1 cubed. Next part, we can actually take this 2, bring it down front, take this 3, that factor is now 3 times x minus 1. There's no more products or quotients inside the logarithms, and so at that point we're finished. So break it apart as a difference and then pull those powers down. Okay. Number 5, log base a of this whole thing right here. So we're going to start by breaking off the quotient as a difference. So we're going to say that's log base a of the numerator minus log base a of that whole denominator. Alright, next step. Again, square root is the same as a 1/2 power. So that's going to be 1/2. I'm going to go ahead and bring that down. And so that first piece is done. Sometimes it's easier just to work with one piece at a time. So that's finished. Now over here we've got x cubed times x plus 1 to the 4th. So that's a product. We can actually break that apart into a sum of two logarithms. And notice what I did there is I put both of those terms, that whole sum, in parentheses. Okay, and the reason I did that is because you're actually going to distribute that minus sign. So you get minus log base a of x cubed minus log base a of x plus 1 to the 4th. And that's a real critical step to make sure you get all those minus signs in there. Just a hint to help you out. The pieces that start in the numerator will be positive when you get to the end. These pieces that are in the denominator will typically be negative when you get to the end. And that's not 100%, but that's a good rule of thumb just to remember. Most of the time that's the way it's going to work out. So to finish this up, We got a 3 here, so we can put minus 3 log base a of x. We've got a 4 here, so minus 4 log base a of x plus 1. Now at this point, we're really not doing any simplifying. You'll notice that looks a whole lot more complicated than what we started with. But again, it's just using these properties, trying to get used to how they work. Now going the other way, it says write each expression as a single logarithm. So we want to take what we're given and try to combine it together into a single logarithm. And really this is the reverse process of what we just got done doing. In those last problems, we try to break it apart into a bunch of small pieces. Here we're trying to put it all back together. So we kind of go backwards, reverse the process. So we can start with this factor here. Let's say that's the same as plus log base a of 3 to the 4th, which is 81. And then if we take that sum, we can put that together as 7 times 81, which is log base a of 567. And so that one is finished. Next one here, 2/3 natural log 8 minus natural log 3 to the 4th minus 8. One thing we can do to start out we can just simplify this 3 to the 4th minus 8, right? 3 to the 4th is 81, and then minus 8 from that you get 73. So no reason to keep that more complicated than it needs to be. We can take the 2/3, put it as a power over 8. 8 to the 2/3 power, if you'll recall, that's the same as the cube root of 8 squared. So that's 2 squared, which is 4, right? And so this is the same as natural log 4 minus natural log 73. And again, you can divide, since that's subtraction, make it 4 divided by 73. And put that together as one logarithm. And that one's done. So it's just the reverse process. Last one here. This one looks pretty rough, but it's not too bad. The first thing we can do is notice there's not any factors in front of any of these logarithms, right? So there's no factors to take and put back up as powers. So what I can do is I can start by looking at all 3 of these first pieces. Those are all one big sum. So I can multiply all those together. And so that's log base a of 9x times x squared plus 1. Since that's minus, we're going to divide by, whoops, let me back up, fix this a little nicer here. It's log base a, that part's divided by 5, not the logarithm, just the part inside the logarithm there. So that one's done.